If you're looking to fine-tune your large language model, then this paper by Yoonho, Annie, Fahim, Ananya, and various others might help you out. Fine-tuning a neural network typically involves retraining every layer on new data, but networks might perform better than before when fine-tuning modifies only a subset of layers. That would take lesser time and lesser resources. And this paper demonstrates that surgical fine-tuning, which is primarily a method that chooses specific layers to modify depending on how the fine-tuning data set differs from the pre-training data. Now, the way this thing works, if you read the paper, which is, and I will share the link in the video's description, is that the authors fine-tuned each layer individually first, producing a new network each time. They identified the best layer to fine-tune by comparing the performance of each network. And then in the automated approach, they calculated the gradients for each layer. They divided the gradients by the magnitude of the layer's weights to obtain relative gradients. Then they normalized the relative gradients across each layer at the beginning of fine-tuning and periodically throughout. Then during the training process, they assigned the learning rate for each layer according to the product of its normalized relative gradient. They evaluated their approach on Cipher-DIC, which is a version of CFAR dataset corrupted with noise. I think this matters because the authors have really done a groundbreaking work here and proposing an efficient fine-tuning method. And because it is always helpful to better understand how a network extracts feature could yield further ways to improve machine learning models. So I believe if you're interested in this theoretical discussion of fine tuner, then this paper is a good starting point. Thank you.